Hello and welcome to this video, where I talk about some basic computer science concepts and how they apply to real-world situations. Today, we're talking about idempotency. No, there's no little blue pill for that. Idempotency simply means that you have an operation that can be applied multiple times without changing the result. So, you get the same output whether you perform the operation once or 10,000 times. Software engineers rely on the network a bit too much. Imagine this scenario. You are on a slow network and you just made a payment. The spinner icon just spins and spins. You get impatient and click on the pay button again. Will you be charged once or twice? In this scenario, the request to process the payment probably reached the server, but the response never got back to you because the network dropped. Never trust the network. As senior developers, we must prepare for unstable networks and basically chaos. Now, in simple mathematical terms, idempotency just means that f of x equals f of x. No matter how many times you perform the action, the state of the world remains the same after the first time. Your application needs to behave like an elevator button. If you press it 10 times, you get to your floor only once, not 10 times. Same should happen when building an API, for example. The get, put, delete methods are naturally idempotent, but the post is the dangerous one. So how do you practically solve this issue? By utilizing a key, let's call it Idempotency Key, that you will send in the header with your request. Let's look at some simple examples of both the danger code and the solution. In the danger code, we have a function that processes a payment. This function maybe gets the user ID and the amount and sets the payment status to false. Then, using some predefined payment gateway, the function sends the payment to the third-party payment gateway, and if we get true, for example, from the payment gateway, we update our database and return success. Otherwise, we assume that the payment failed and return the string failure or failed. Now, what happens if the network dies after the payment is sent? Our payment status remains false, the database isn't updated, and naturally the user tries again. This means that the user will be charged twice for the same payment, and that will not make them happy. A much better way to handle this situation is to pass an idempotency key to our process payment function. Each payment instance has a unique key that we store in our database. Before we send the payment to the gateway, we check whether such payment has already been made. If so, we simply return the information about this payment so that the user knows that they made payment and they won't be charged again. If we don't have anything in the database, then we send the payment to the payment gateway, update our user balance, for example, and update our result, and we update, basically insert a new row in the database that corresponds to this new payment. Of course, we can wrap our database actions in a transaction to make sure that no record is stored if something goes wrong. Using the idempotency key means that you're utilizing defensive architecture. We accept that the network can be broken, and we build systems that don't really care about that. Thinking about the big O notation, without idempotency, you're having an ON application, where N is the number of times that the network fails and the user retries the operation. By implementing idempotency, you are squashing the application to O1. Here's the practical reality. Imagine you're running a flash sale. Thousands of users are hitting buy at once. The server lags, the load balancer drops connections, and desperate users start spamming the submit button. In the danger architecture, your support team will spend the next 3 days manually refunding double charges and fixing corrupted inventory counts. In the defensive architecture, the system stays silent. the database handles the unique keys, the duplicate requests are ignored, and you, the engineer, can focus on developing the next amazing feature. So the next time you're building a post request that moves money or changes state, don't just ask if it's fast, ask if it's safe. Stop fixing the symptoms of a broken network and start building an architecture that expects it to fail. Thank you for watching. If you like what I do, please like, subscribe and share. Or even better, buy me a coffee. Till the next time, stay defensive.